Hello everyone and welcome back to Turner's Tutoring. I'm Mr. Turner with our math video today. We are going to be doing an upper grade level math video centered around decimals. So we've done a decimal video already on the basics of decimals. Now we're going to come into a lesson called comparing decimals. We're going to be focused on using the number line and ordering them based off of place value, and then we have a quick question we're going to answer. So let's go ahead and get into this. Remember that we're comparing decimals. Now, just a quick refresher, when we are looking at things, we've got less than, equal to, and greater than. We're going to be using those symbols in order to compare the decimals. Let's go ahead and get into it.
Drag the decimal numbers to their position on the number line.
So, we're going to look at our whole number of the decimal first to help us place these, and this is going to be a little bit more easy to do based off of that. But if we look at between 15 and 16, and then between 16 and 17, and then 17 and on, we can kind of order these and put these in the correct place just based off of the whole number. So I see a 15.8 or 15 and 8, and I see a 17.2, or you could say 17 and 2. I'm going to focus on the 15 and 8. I'm going to take it, and I'm going to put it between the 15 and 16 because I know this goes between those two. Now, the 17 and 2, or 0.2, will go after the 17 because it's bigger than 17, and we're going to put it there. Now, we were able to look at the whole numbers to do this, but there'll be some questions that come up that have us working on between the two same whole numbers.
Choose the correct comparison symbol.
Now remember, less than, equal to, greater than. We are going to create kind of like a word sentence with this in what we are saying. So 15 and 8 is something to 17 and 2. We know that it is less than. This one is smaller than this one, so we're going to say less than. We're going to plug that in.
Drag the decimal numbers to their position on the number line.
Now, same thing. Now, this is where it gets a little bit more complicated, though it is helping us out because it still shows, hey, if we look at the first or the largest place value, which right now is the 10th, I've got a 3 in the 10th place right here, and I've got a 1 in the 10th place on this one. And I've got my number line set up in 0.1, 0.2, 0.3, 0.4, and so on and so forth. With that being said, this helps me to guide where I'm placing these numbers because I'm looking at that first place value. I know that the 0.1 needs to go after the 0.1 and before the 0.2. And so 0.155 is between 0.1 and 0.2. This would be read 155 thousandths. That thousandths tells me, or that ending place value of what I'm ending with tells me where my place value goes to, and so on and so forth. 355 thousandths goes between the 0.3, or the 3/10ths, and 0.4, or 4/10ths.
Choose the correct comparison symbol.
So on my number line, I have 355 thousandths is bigger than 155 thousandths, but on my statement, I am reversing the order in which they're coming, but I'm still going to say the same thing because I know that it is bigger. I'm going to use the greater than symbol because it's larger, and that gives me the answer.
What number is the arrow pointing to? Choose the correct decimal number.
So we're going to say this line is right in the middle of 1 and 1/10ths and 1 and 2/10ths. If it's right in the middle of those, I know that I can't go before it. I know that I can't go after the 1 and 2/10ths, sorry. I messed that up. So I can't go after, and I can't go before the 1.1. I need right in the middle of these two. So this could also be read out with the tenths. We could put a 0 if that helps. The 1.10 to 1.20. So the 10 and 20. 15 is right in the middle of 10 and 20. Hopefully that makes sense and helps as well. So we're looking at 1.9, and 2 is the whole number, right in the middle of that. We have 1.9, like we said in the last one. 1.90 is equivalent or equal to 1.9. They mean the same thing in this case, but you could also say they were equivalent. Sorry, 1.85 comes before 1.9, and so it'd actually be in this spot right here. So our answer is 1.95. That becomes between the 9 and the 2 holes. So I'm going to, for this one, count how many times I need to jump, and that's going to tell me where this lands. I know it's not 3.5 because I see 3.5 on the number line right here. So I'm not going to answer it that. But between 3.4 and 3.3, I'm not sure. So I need to count it. I'm going to go 1. So that's what would be 3.1, 3.2, 3.3, and 3.4. So that tells me my answer. So I know I said I was going to go on to the others, but this turned into a longer video just focused on number lines. So that's just what we're going to focus on with this video, is comparing the decimals utilizing number lines. I'm going to say that again so it's a little bit more clear and I'm not stumbling over it. We have compared two decimals utilizing number line, and a little bit more because this is a 5th grade concept. We did it to the thousandths place value. Thousandths is 3 digits. You've got tenths, hundredths, thousandths place value. And just another quick refresher again, we used less than, equal to, or greater than to compare these fractions. Thank you for joining me for our math video. I'm Mr. Turner with Turner's Tutoring, hoping that you guys benefited from this, and if you did, please like, subscribe, and share the channel with someone that would benefit as well. Thank you guys for joining me for our math video in comparing decimals to the thousandths place value utilizing number lines. Have a fantastic rest of your day.